Okay. So last time we talked about Miller planes and the general directions and how they describe reciprocal space. And as we're looking down a lattice, it gives us a way to view that lattice in a different manner. When we get to surfaces, it's going to become important because the chemistry changes a lot depending on the cut you have. And then in a little bit, when we talk about X-ray diffraction experiments and the outputs from those diffraction experiments, how can we look at that and get something chemically or physically meaningful? And it all derives from the Miller planes. Okay, but last time, I gave you only systems that had a value greater than 1, or 1 or greater. But what does a value of 0 or a negative value mean? Yeah, Joe. Yes, that's exactly what happens, but you can adjust. But we're going to talk about how you make those adjustments, what it looks like, and what does that actually mean. So the first question that we want to address is what about if the Miller plane runs parallel to one of the axes? What about a plane runs parallel? What we say is there's an intercept somewhere in infinity. Intercept is infinity. So let's say we're talking about the first plane. So if we have a 1, 0, 0, where is our x-intercept? Yep, it's at A, the lattice vector. What about the y and z? Yep. Okay, and remember we have the planes h, k, and l. H was equal to A divided by Y intercept. So we would get A over A, which is equal to what? 1. Okay, let's just take K as our example. We have B divided by intercept, which is equal to B over infinity. What can that be approximated to be? Yeah. So that's what happens there. So let's draw a lattice. We liked blue, right? Blue and yellow? Okay. So
I'm going to wear a Christmas outfit. That's the screw It's the most egregious.
I'm nervous, so
I have 26, apartment 5, bedroom, what, 8?
you guys are just talking insanity right now. No idea what you're saying. Okay, so we have these Miller planes. We want to draw them for a cubic lattice. So let's draw our cubes out. Got to have 3 of them. Oops. Okay, we have to indicate our axes planes. Z. They're not going to be any different for these ones. Okay. Let's write them out too, which one we're going to label which. Bless you. Okay. Everybody got that semi-scrambled down? Okay, 1, 0, 0. What plane is this going to run parallel to? Or planes? Mm-hmm. Y and Z. And which one's going to be intercepted? Yep. So where should I fill in? So X goes to that point, right? The others don't have an intercept there. So what does this look like? Yep, just this front face here. I'm going to mark all of these edges because in reality, it's a unit cell, it's repeated. And I'm talking about that plane. Actually, is it better if I do the wavy thing rather than? Okay. 0, 1, 0. Which one am I intercepting? Y. Yep. And it's yep. Z. Oops. 0, 0, 1. Which plane am I intercepting? Not A. Yeah. Okay. Now, if I ask the question, are these actually different in a cubic lattice? No, they're not different in a cubic lattice. So most of the time it would just be represented as this because they just want to hit the first non-zero digit that way. Which one of those looks the most visually appealing to you in terms of the numbers? I like 0, 1, 0.
I like 0, 1, 0.
It's symmetric, but this is more convention.
Ooh.
So just adjust the biggest number to the front. However, if I went with like a rhombohedral or a tetrahedral, are these planes equivalent? They are not. That's when it becomes important. Okay.
Are we getting it?
Please do. What's your question?
No.
How is it parallel? How does it end up being parallel to Z if it's like if you do it across all unit sets? Like, does that make sense?
Yep. So it never, this will just keep going along that face. It will never actually cut. But you're saying like, what about the one behind it, right? Because isn't it touching that? Yeah, it is, but it's never actually passing through Z. It's like right on the edge.
But it doesn't technically cross it.
Yes. But you will sometimes see that not represented this way, but they'll just fill in back here. You have to know that those two things mean the same. Or in some cases, you'll see that where the back part is also filled in. So it'll fill in both of those planes. Joe, did you have a question?
Yeah. So are we going to? I mean, I don't know if we're going to today, but are we going to cover what else?
No, we're not going to talk about hexagonal structures in this class. It's just too complicated and takes too much time, and I don't feel like there's much benefit. I also want to get to electronic structure really, really bad.
So,
No HLKI. We won't have to worry about that one. There's another lattice plane for hexagonal systems.
How do you know this?
YouTube.
I went a little too deep by accident.
Yep.
I
That's okay. It's good, but that's really a graduate level thing. I just want to give you an appreciation of it. Okay, any other questions about planes going parallel? No.
Although I do find a lot of stuff.
Yeah, it is really cool. And it's a lot of material science.
You can go to Rochester.
Yep. Or UB or, yep, Corning's a good one. Alfred University. Yeah. They have a PhD program. Okay. Yep. Yep, actually, my good friend's wife, they met on Tinder. He had a PhD in chemistry, and she also has a PhD in, I think, like material science. Met up completely by random. Like, how does that happen? Like, the fraction of humans that have a PhD.
That end up on Tinder, it's gotta be.
I'm sure it's way higher now. But.
Yeah,
I was gonna say, I feel like those things could be,
like a doctor of philosophy and
I mean, I feel like doctors.
No, we just show up on Yik Yak all the time. Dr. Ogawa trying to shop, poor guy.
Yeah.
Okay, but what about, so when we talk about these Miller planes, what about when we have a negative value? What does that translate to? So when you do this, you may need to draw multiple unit cells, or you have to shift your axis. I think it's easier to shift it than it is to draw multiple unit cells, erase that unit cell, and get back to a general picture. But it depends on your preference completely. Both methods are correct and it's fine. So you may need more unit cells, or you need to shift your origin.
N bar or negative?
N bar is a negative value. So let's look at an example. Let's say we have a 2, 1 bar, 2 plane that we want to draw. Okay. Okay, and my coordinates, normally we have the origin in the back left corner, right? Or correct? Roger.
yes.
X, Y. Okay. Let's look at those numbers. Where would the intercept be for this system? So, yep, we would have halfway through the X. Then, where else? Halfway through the Z, and then where else? Yeah. Halfway through that -1, and then you have no idea what it looks like within the unit cell. So instead of doing that, what I suggest to do is shift your axis. Okay, and where I'm going to move the axis, it really depends on how you want this visualized. I'm going to move it to this point.
That's why you care about
Yes, it's generally, but you don't always have to label your X, Y, and Z. Some people would elect to continue this plane out. To me, that seems more confusing. Okay, so now Let's look back at our Miller planes or interception points. What do we got for x again? Okay, so where would the 1/2 be in this picture? Yep, on the right side. There. What else? Yep, so right along there. And then my y.
Back left corner of the third.
Yes. Over here.
Go in the corner.
Yeah, in the corner with you. There you go. So it would be shifted that way. Does that make sense to people, or can you visually see it? Okay, let's go with a couple more examples where we'll have to move it in different directions. Am I okay to erase this side? Okay. So, oops, need white. Example, draw the following Miller planes. Oh, we just did this one.
They're either 3 hours or 30 seconds.
I don't think I spent more than 30 minutes.
Yep, the analytical ones take a long time. Oh, I don't know about
We don't
those.
talk about those.
Yeah, we don't talk about that.
I hate computer math.
You teach it like-
We don't have to computer math, we just have to write the answer.
I know, just to me.
Did I teach analytical here?
No, like the adder.
Yeah, I taught it at Alfred State.
Oh, okay.
Yep. I like it. It's good.
Is it? I heard it was. I didn't know that.
State or kind of
No, I knew we called it out. State, just where you,
Yeah, I taught a lot of different stuff.
And your favorite was this.
My favorite is quantum, by far. This class I like a lot. I'm learning a lot. I don't know if I like it all as much as quantum chem yet.
Is that one of our options?
Yeah, it's PChem 2. PChem 1 is thermodynamics. I really love thermodynamics, but students hate it. No, just because it's hard. And you really don't get the point until you know all of it.
Most people hate that lab.
Yeah. Okay, so now we have these Miller planes. We have to indicate what they look like, and we have to draw their coordinate system. Some of them we'll have to shift, some of them we won't have to shift. Okay, this first one, the 1, 2 bar 2. Where should we draw our origin?
The left back corner. Or right back corner.
Yep. That's where I would go also. Why did you pick that direction?
We're going negative on the y.
Yeah. Okay. Now let's mark our points where they intercept the axes. A value of 1 for x. Where do we put that? Yep. A value of -2 for y.
Back middle.
Yep, back middle. And then a z of 2.
Back up middle. Back up middle. I don't know what's
What's all different labels and
No. Memorization is not the way to go. Okay, now for B.
let's give them all symbols.
So we're going John 1.
Okay, so now we have 1 bar, 0, 1. Where would you put the origin? Front left, that's where I would go. X, Y, Z. This one's a little difficult because it has to not intercept which one? Y. Okay. So let's try to draw this one out. Where is going to be the point of interception on the Z coordinate? I'm sorry. Yes, you're right there. Should be up here. What about for X? That's the one I wanted to ask. Yeah. Okay. We know there's a 0 here. So there shouldn't be any point marked along here, correct? However, we know this has to be a plane. We can't have a plane with just 2 points. What do we have to do? Yep. So we'll put one here. And what about that guy? Right. We don't want anything in the Y, but remember, this is at the origin or one of the edges of the unit cell, and it can be reflected on that side.
Oh, and this time we're drawing up an actual plane.
Yeah. This plane is cutting the unit cell in half, basically. Yeah.
But it's not.
Right.
That's so cool.
So it's coming out towards us. Do people see that one? Okay. 111, I think I had you do for your homework. Where should we put the origin? Yep, back left, usual spot. Okay, where are my points that intercept the axes? Yep, specifically. Yeah, so A, B, C. Okay, now 311, where should we put our origin? Yep, usual spot. Where are my points of, where am I going to intercept this?
Third from third A.
Yep, third of A. What about B? Yep, all the way to the edge, and then Z. Yep, all the way to C.
Pretty scientific descriptions, right?
Yeah, over there.
And the peacock.
Okay. Do you feel like you can identify those planes? Feel like you can shift things and move it about to where you need it to be? Okay. This is important. If you know this, when we get to more complicated stuff, we can distill things down and make things way simpler. Okay? Am I all right to erase this?